Right now, 300 feet beneath the polished shoes and coffee shops of downtown Chicago, there is a labyrinth. 110 miles of massive tunnels, some wide enough to drive a school bus through, carved directly into ancient bedrock. Connected to underground reservoirs so enormous they could swallow entire stadiums. A system capable of holding 17 billion gallons of liquid. And most people walking above it have absolutely no idea it exists. It wasn't built for transportation. It wasn't a Cold War bunker. It wasn't designed for the military. It was built because the city of Chicago was slowly poisoning itself. See, here's the thing most people don't realize. Chicago is flat. Not gently rolling hills flat. Swamp flat. The entire city was built on marshland barely above the waterline of Lake Michigan. And for over a century, every home, every office building, and every restaurant flushed its waste into the same pipes that carried rainwater. One system. Sewage and stormwater, all mixed together. On a dry Tuesday, fine. The system could handle it. Interceptor sewers would redirect everything to treatment plants downstream. But when the skies opened up, catastrophe. The pipes would hit capacity in minutes. And when there was nowhere left for the water to go, millions of gallons of raw, untreated sewage, human waste, industrial runoff, a murky, toxic sludge that stank like death, would blast backwards, up through floor drains, into basements, across streets, and straight into the Chicago River, which emptied directly into Lake Michigan, the same lake that millions of people drank from every single day. By the 1960s, Chicago sewers were overflowing more than 100 days a year. Think about that. 1 out of every 3 days, a toxic cocktail of raw sewage was surging through neighborhoods, contaminating the city's own drinking water supply, and turning the river into something residents described as an open sewer. You could smell from blocks away. The flooding destroyed homes. It ruined businesses. It threatened the health of millions. And every proposed fix ran headfirst into the same brutal reality. You cannot tear up and rebuild the sewer system of one of America's largest cities, not without ripping apart every road, every building foundation, every block. The cost would be astronomical. The disruption, unthinkable. Officials assembled a task force. They studied over 50 different alternatives. Bigger pipes, retention ponds, surface reservoirs. One by one, every conventional solution fell apart under the weight of Chicago's geography, its density, and the sheer, staggering volume of water involved. Nothing was big enough. Nothing was fast enough. Nothing would work. But then someone proposed an idea so audacious, so wildly ambitious, that it sounded less like civil engineering and more like science fiction. What if they didn't build outward at all? What if instead they went down, 300 feet straight down, and carved a hidden empire into the ancient limestone bedrock beneath the city? The plan had a name. They called it TARP, the Tunnel and Reservoir Plan. But the engineers who dreamed it up knew what everyone else would call it. Insane. Because what they were proposing wasn't some upgraded sewer line. It wasn't a bigger pipe or a deeper ditch. They were proposing to build an entirely separate city beneath Chicago. A shadow infrastructure. Over 100 miles of tunnels, some stretching 33 feet in diameter, wide enough to fit a 3-story building inside. All of it carved into rock that had been sitting undisturbed for over 400 million years. Silurian dolomite, ancient limestone bedrock so dense, so brutally hard that it had survived ice ages, tectonic shifts, and the full geological violence of deep time. And now, a team of engineers in hard hats wanted to bore through it like it was nothing. Here's how the system was supposed to work. Across the city, engineers would sink vertical shafts, massive concrete cylinders punched straight down through 300 feet of earth and rock. These drop shafts would connect directly to the existing sewer network on the surface. So when a massive storm hit and the old pipes started to overflow, instead of the sewage surging backwards into basements and the lake, it would be captured, redirected, funneled into these shafts. And then it would fall. 300 feet. Straight down, millions of gallons of water and raw sewage plummeting into darkness at terrifying speed, slamming into the tunnel network below with the force of a freight train hitting a concrete wall. Now stop and think about the physics of that for a second. A single gallon of water weighs about 8 pounds. Now imagine millions of those gallons in free fall, accelerating under gravity for 300 feet. The kinetic energy at the bottom is enormous. Violent. The kind of force that doesn't just fill a tunnel. It tries to destroy it. The pressure waves alone could crack rock, shatter concrete, and blow joints apart from the inside. And the critics said exactly that. Politicians called it a multi-billion-dollar gamble with taxpayer money. Skeptics argued the tunnels couldn't possibly withstand that kind of hydraulic punishment, storm after storm, year after year. Engineers from outside the project warned that the drop shafts would create pressure surges so extreme they could rupture the entire system from within, turning an underground reservoir into an underground bomb. The price tag alone was staggering. Initial estimates came in around $1.2 billion. But everyone involved knew that number was a fantasy. A project this large, this unprecedented, burrowing through bedrock beneath a living, breathing metropolis. Costs would spiral. Timelines would stretch. And if a single miscalculation cracked even one tunnel segment 300 feet underground, there would be no quick fix. No patch job. Just millions of gallons of sewage flooding through fractured rock beneath the foundations of a major American city. The risks were enormous. The engineering had never been attempted at this scale, and the only thing more terrifying than building it was the slow-motion catastrophe of doing nothing. So they started digging. Now here's the first problem you run into when you decide to carve 100 miles of tunnels beneath a living city. You can't blow it up. Dynamite was off the table from day one. 300 feet above those tunnel routes sat apartment buildings, office towers, hospitals, schools, millions of people going about their daily lives. One miscalculated blast charge, one fracture propagating the wrong direction through the bedrock, and you're not just cracking rock, you're cracking foundations. You're collapsing basements. You're creating the exact kind of catastrophe you were trying to prevent. So the engineers turned to something else entirely. Machines. Enormous mechanical beasts called tunnel boring machines, TBMs, and the ones built for Chicago's deep tunnel weren't ordinary. They were among the largest hard rock boring machines ever constructed at the time. Picture a steel cylinder the length of a football field and the weight of a commercial airliner, fitted with a rotating cutter head, studded with dozens of industrial disc cutters made of tungsten carbide, one of the hardest materials on Earth. And then imagine feeding that machine into 400-million-year-old dolomite bedrock and telling it to chew. The noise alone was staggering. Workers described it as a relentless, grinding roar that vibrated through your chest, your teeth, your skull. The cutter head didn't slice through the rock, it crushed it. Each disc applied thousands of pounds of force to the tunnel face, creating stress fractures that splintered the stone apart in chips and fragments. Sparks erupted where carbide met ancient limestone. The temperature at the cutting face could climb so high that workers operated in shifts, rotating in and out of the heat, the dust, and the deafening mechanical scream of steel against earth. Behind the cutter head, massive conveyor systems hauled the crushed rock backwards through the tunnel and up to the surface. Millions of tons of it, day after day, month after month, year after year. All of it removed from beneath Chicago's streets while the city above barely noticed. And the tunnels themselves. The largest, the mainstream tunnel, stretched 35 feet in diameter. Wide, enough to lay a 3-story building on its side and roll it through. Bored through solid limestone between 240 and 350 feet underground. When it was finished, that single tunnel alone could hold 1 billion gallons of water. But the tunnels were only half the plan, because even 100 miles of underground pipes can only hold so much. The real anchor of the entire system, the thing that turned TARP from ambitious to borderline insane, were the reservoirs. Specifically, a place called the Thornton Composite Reservoir. Imagine standing at the edge of a cliff and looking down into a man-made canyon, 2,400 feet long, 1,500 feet wide, 300 feet deep. So massive that locals started calling it the Grand Canyon of the South Suburbs. Engineers calculated you could fit 12 soldier fields inside it. The entire village of Thornton could sit comfortably on its floor. And this thing was carved out of the earth 1 truckload at a time. The reservoir was built inside an old limestone quarry south of the city, and to get it to the depth and volume TARP required, mining crews had to remove 76 million tons of dolomite rock. Let that number settle for a moment. 76 million tons, enough crushed stone to bury a small city. And it all had to come out on trucks, through a working quarry, while an interstate highway ran directly over top on a specially constructed dike. At the bottom of the reservoir, 500 feet below the surface, sat a natural layer of impermeable shale, ancient geological bedrock that acts like the bottom of a bathtub. Nothing gets through it. Engineers sealed the perimeter with a nearly 2-mile-long grout curtain, built a 112-foot roller-compacted concrete dam to separate the reservoir from the active quarry next door, and plugged old mining tunnels with solid concrete. When it was finished, the Thornton Composite Reservoir could hold 7.9 billion gallons of combined sewage, the largest facility of its kind ever built, anywhere, on Earth, and all of it hidden below the surface, out of sight, while 500,000 people in 14 surrounding communities went on with their lives, completely unaware that the thing keeping sewage out of their basements and drinking water was a subterranean cathedral of engineered stone sitting quietly beneath their feet. Then the storm came. Clouds stacked over Lake Michigan like bruised fists. The sky turned black at 2 in the afternoon, and when the rain hit, it didn't fall. It hammered, inches per hour. The kind of downpour that turns roads into rivers and overwhelms everything in its path. Across the city, water surged into storm drains. Gutters overflowed, streets flooded within minutes. The old combined sewer system hit capacity almost instantly, and millions of gallons of rainwater laced with raw sewage began rising through the pipes with nowhere to go. But this time, it didn't reach the surface. This time, the water hit the drop shafts. Hundreds of capture points scattered across the metropolitan area funneled the overflow downward, not into basements, not into the river, not into Lake Michigan. Down, 300 feet through vertical shafts and into the waiting darkness below. Millions of gallons in free fall, slamming into the tunnel network at speeds approaching 30 feet per second, surging through 110 miles of carved bedrock like blood through arteries. The system drank the storm whole. Water roared through the mainstream tunnel, through the Calumet system, through the Des Plaines network, all of it flowing by gravity toward the mega reservoirs. At Thornton, the floodwater poured from the tunnel mouth into the vast open chasm of the reservoir, slowly rising foot by foot across that enormous limestone basin. The floating aerators kicked on. The pumps stood ready. And above ground, a city of nearly 3 million people barely got their shoes wet. The numbers, when you step back and look at them, are almost impossible to process. Since the first tunnels came online, the system has captured over 1 trillion gallons of combined sewage. That is not a typo. 1 trillion gallons of toxic waste that would have ended up in basements, streets, and drinking water. Captured, held, treated, and released clean. Before TARP, Chicago's sewers overflowed more than 100 days a year. After the tunnels were completed, that number was cut in half. And in the areas served by the Thornton Reservoir, combined sewer overflows have been nearly eliminated entirely. But perhaps the most stunning result isn't a number at all. It's the river, the Chicago River, the same waterway that was once so polluted it was considered biologically dead, so toxic that nothing could survive in it, now hosts more than 70 species of fish. Wildlife has returned to its banks. Marinas and riverside restaurants have opened along its shores. Waterfront real. Estate has skyrocketed. People kayak on it. Some even swim in it. A river that was once an open sewer has come back to life. And the thing that saved it, most Chicagoans have never seen it. Never will. Right now, as you watch this, somewhere beneath the coffee shops and taxicabs and commuter trains of Chicago, there is a fortress in the dark. 110 miles of carved stone sitting in silence 300 feet below the street. Empty, still, waiting. No signs mark it, no monuments honor it. It doesn't ask to be noticed. It just waits for the sky to turn black again. And when the next storm comes, and it will come, that silent, invisible labyrinth will open its throat and swallow the flood whole. Just like it always does. Just like it was built to. The greatest engineering marvel most people will never see. Sitting right beneath their feet. If stories like this remind you why engineering is the closest thing we have to real-world magic, subscribe. We've got a lot more to show you.